This next section is entitled, Where is the Water? But really it's a question of what form does the water take? In total, we have 1,386,000, there's an additional times 1,000 cubic kilometers of water on the planet, most of which is in the oceans. Most of which. Right? 96.5% of that is in the oceans. The next biggest percentage is ice and snow. So these are our glaciers and permanent snowpacks at 1.76%. Right? We then have salinated groundwater, fresh groundwater, lakes, salinated lakes, moisture in the soil, atmosphere, and so on down. And depending on where it is determines how long it on average spends there. So a molecule of water in the ocean could be there for 3,000 to 30,000 years. In ice and snow, it could be up to 100,000 years. It just depends. Right? Because the oceans have 97% of the Earth's water, and it stays there for so long, they are the things that moderate the Earth's climate. So things to think about is, what are the currents doing? How are they circulating? What does it look like? So if you think about the North Atlantic, you have the Gulf Stream, you have the Labrador Current, and you have the North Atlantic drift currents, all combining to form a complex whole. So here's the Gulf Stream coming up. It changes into the North Atlantic drift current, and then you have the Labrador Current coming down from the north through Canada, meeting up with it. The Gulf Stream, since it's coming up from the equator, is warm. The Labrador Current, as you might guess, is cold. Here is a map showing the ocean water temperature where those two meet. Notice very, very red coming up. This is the Gulf Stream. And here is the Labrador Current coming down, the blue. For reference, there's Florida. .4% of Earth's water is fresh water. Now, some of that is in the form of ice and snow, some of it is form of liquid water like in lakes. Right? 10% of that is in surface, rivers, streams, lakes, and groundwater. The other 90% is your glaciers, ice caps, and snowfields. So what is a glacier? A glacier is actually a stream or river of ice that flows down because of gravity. The dots on this map show where the glaciers are at present on the planet. About 10% of today's land area is covered by glacial ice. It's been more. There was 30% during the last ice age. And because so much of the water was trapped in ice, the sea level dropped from 200 to 300 feet. Mount Rainier in Washington is a 14,410 foot volcano, very much covered in ice and snow. Here is a picture of a glacier. As I said earlier, the time a molecule of water spends in a glacier could be from 1 year, it could be 100,000 years. Just depends on what happens. Groundwater makes up 1.7% of the Earth's water. It could be there from a day to thousands of years, depending on where it is and how it's trapped. Precipitation is the main source of groundwater. You have precipitation that falls and then it percolates down into the water table and becomes part of groundwater. The water table is a boundary and is in flux. It goes up and down depending on how much precipitation is falling at a given time. When you have a well, you get a cone of depression around that well. Right. Waters from other areas moves in to replace, to unify the levels. If you want to keep using this well, however, you're going to have to keep drilling down further because of this depression. It never quite refills 100%. So how do we recharge the water table? You have to have groundwater that flows in, which requires precipitation. Rivers and streams make 0.0002% of Earth's water, and water in a stream is only there from a week to a month. Right. So water that does not infiltrate, meaning water that doesn't go into the ground and become part of the groundwater system, it runs off to form streams and rivers. Streams and rivers carry sediments, erosions, chemicals, matter with it. There are several different types of sediment. We have bed load, which are little rocks kind of rolling along the ground. Right. The saltation load actually bounces along the ground instead of rolling. Suspended load is held in the water and moved along. And there's also a dissolved load, which means it's in solution. Salt that's in a stream would primarily be dissolved, for example. Right. So surface runoff is a local problem, right? So, in other words, runoff occurring in West Virginia has no effect on surface waters in Maryland. Wrong, because remember, we are in the watershed that flows into the Chesapeake, right? So any land that is in the watershed for a particular area causes a problem if it gets contaminated. So generally, the larger the basin, the less sediment yield because small basins tend to be steeper. The lower Mississippi, so down here, has 18,220 tons per year, whereas the Missouri only does 5,250 tons per year. There's also this problem of drainage from mines, particularly if the material that's deposited from the mining process is acidic. Here you can see what might have been a beautiful, pristine stream is now this orange due to the acid quantity, acidic nature of the water flowing through it. This is a picture of a portion of the Mississippi River. Not sure where in the U.S. this particular picture was taken. Right. The Mississippi River Basin, this entire area, is the source of the nutrients causing the dead zone at the mouth of the Mississippi. Remember, in this dead zone, there's no life. It can't grow. Here is a picture of the Mississippi Basin. Notice this is Louisiana, and the Mississippi empties out through New Orleans, Louisiana. Right. And the red here indicates areas where life cannot be sustained. That's our dead zone. Here is another version of it. Look at how turbid the water is at the Mississippi Basin. It's all cloudy. Right? Anything shown in light blue is hypoxic, meaning it has excessive nutrients and, again, won't support life. This is an image of the Potomac River in the past at Harper's Ferry. This is the train bridge that is still there. I believe it's now the one you can walk across. This is that same bridge. Here is a picture of the Chesapeake Bay watershed, which the Potomac River is part of. This is a bridge, I believe, across the Mississippi. I'm not sure where again. But something to think about, the 16 largest rivers carry half of all surface runoff on Earth. Right? The Amazon, which is the Earth's largest river, has a discharge rate of 175,000 meters cubed per second, which is 10 times what the Mississippi can do. Here is a picture of the mouth of the Amazon. So you can see like this little blip here on the map is this one here. See all the sediment that's being deposited with it. This is the Nile River Delta. Similar idea. Again, lots of sediment. The sediment can form an alluvial fan. When it comes out, it fans out. There's also the North Pacific Gyre. This is the trash vortex. There is a YouTube video link right here. I will post that for you to watch separately on the, it gives you information on the gyre. This is a picture of what's in the trash vortex. Okay, so lakes and wetlands are 0.014% of the Earth's water with a resident time of 1 to 500 years. Lakes hold water year-round. Wetlands are saturated at least part of the year, but maybe not all of it. But they're very important. Wetlands serve to stabilize soil. They slow runoff and aid infiltration. They aid water getting down into the ground, the water table and the groundwater. In the U.S., 20% of land used to be wetlands. Half of these have been drained, filled, or degraded over the past 200 years due to agriculture or development.